Bismillahirrahmanirrahim. In today's discussion, we'll continue talking on some practical examples related to the topics we have already discussed in previous lectures. So in today's lecture, we will be focusing on main memory management and how we can code its technique. The technique that we are focusing on in today's lecture is fixed partitioning. We have already discussed two types of partitioning for main memory in chapter 6. Two types of partitioning we have discussed, dynamic and fixed. So in today's discussion, we'll be talking on fixed partitioning. What are the problems it creates and how we can code fixed partitioning using some programming language. So let's begin our discussion. This is the discussion agenda in front of you. First, we have to recapitulate what is fixed partitioning and the problem it creates. The common problem that fixed partitioning creates is known as internal fragmentation. How it is created? We will be recapitulating this, and then we will go on making a code for fixed partitioning and we'll see its output. So let's start with our first topic in the agenda, that is fixed partitioning. What is fixed partitioning? You all must know about it as we have already discussed it in chapter 6. So let's revise what all we have studied. If the RAM has been divided into collection of non-overlapping regions, as the one shown in the image, so such partitioning is known as fixed partitioning. Since once they are created, they are now fixed and cannot be changed. You might have created partitions of your memory, so you would be having an idea what a partition is. And if the RAM has been divided into chunks of regions which are permanent, so such partition is known as fixed partition. Fixed partition commonly can be seen in two forms, either equal or in unequal sizes. The partitions are in either equal or unequal sizes. If all the divided blocks are of same sizes, as you can see in this diagram, all the blocks are of 8 MB. All the blocks are of same sizes. So it is known as equal sized fixed partitions. But on the other hand, if the blocks are of unequal sizes, as you can see in this image, all the blocks are not of equal sizes. So this is now known as unequal sized fixed partitions. But remember, either they are equal sized or unequal sized. Once they are created, they cannot be changed. If a slot is of 8 MB, it must remain 8 MB. And if a slot is of 16 MB, it must remain 16 MB always you cannot change the size. Whatever size of blocks are, as I just said, once they are created either equal or unequal, they are then fixed and you cannot rearrange or reorganize them. In the figure you can see equal blocks of 8 MB slots each, with 8 MB at the top being occupied by the kernel. Operating system, as you can see, kernel is a part of operating system or function of operating system, while the rest of all the slots are of equal sizes and they are available for user tasks. While in unequal size fixed partitions, you can see different blocks having different sizes of slots, and kernel occupies space at the top of the RAM. So if a process is small in size than the partition, so it would occupy whole partition. For example, a process of size 2 MB would reside in 8 MB slot. It would utilize 2 MB while waste 6 MBs. Now let's see how internal fragmentation is created by fixed partitioning. With the use of fixed partitioning, the use of main memory is highly inefficient. And this is one of the drawbacks of fixed partitioning, because any program, no matter how small it is, it occupies the entire partition. For example, if size of program is 2 MB and it occupies 16 MB partition, so memory use becomes inefficient as 14 MBs go waste. That means another fragment is created within the partition, and this problem is known as internal fragmentation. A fragment inside a fragment is created. Complete partition is not utilized by the process. Why so? Because the process is not able to utilize whole of the 16 MBs and would only use 2 MBs, leaving remaining of the 14 MB space as waste. Neither it is using itself, nor this 14 MBs is available to be used by any other process. This problem is very much evident in equal size fixed partition, as all the partitions are of same sizes, and a process would waste same size of partition no matter in whatever partition you placed it, either on top, in center, or at the bottom of the memory. But unequal fixed partition lessens this issue. How? As only smallest available partition, which can accommodate the size of the process, will be utilized, and less internal fragmentation will be created. For example, a 2 MB process, if placed in 16 MB partition, will waste more space as compared to 8 MB slot. But still the problem exists though it becomes lesson. IBM operating system multi-programming with fixed number of tasks used equal size fixed partitions, and they may not be present in today's latest operating systems. Now, as we have recapitulated the topic fixed partitioning and the problem it carries, so let's now make a code that would show how fixed partition can be displayed. This is the code snippet. Complete code is provided in Word document attached on KCMS. In this code, we are trying to create partitions for specific memory. So, you would be required to enter partitions, number of processes, and size of the partition. And then the code will calculate if there is any internal fragmentation associated with any process, how much size is wasted and how much size is being utilized by specific process. Now let's see what can be the possible output. Once you will execute the complete code as provided in the Word document, so this will ask you to enter some information. For example, you would be asked to enter memory size, the size of the memory that you want to divide among different processes. For example, you have 8 MBs that you want to divide, you have 20 MBs, whatever size you would like to divide among processes. So you have to enter the size of the memory, the number of partitions that you want to create, and also the size of the partitions. Either you can make them equal sizes or you can make them unequal sizes. Then the number of processes would also be required to be entered and respective memory size of every process. So these are some of the inputs that are required from you. And after receiving the input, the code will then eventually calculate internal fragmentation associated with every process. How much size, how much memory is being utilized by the process and how much is being wastage as internal fragmentation. I hope you would execute the complete code as attached in Word document and see the results yourself. That is all for now. I thank you all.